Okay, talking about arc lengths and areas of sectors. Now, each are going to be created by two radiuses, or radii. There's a radii, there's a radii, a radius and a radius. Say that's A, and that's B. From point A to point B right here, that's an arc. Now, give it a second to kind of focus in here. Now, in order to calculate the length of an arc, the first thing you need to know how big the central angle is. Now the central angle, there's point C, that's your center. The central angle is created when you have an angle whose vertex is the center of the circle. So the central angle it's an angle whose vertex is the center and sides are radii. So when we're calculating the arc AB, we write the arc with the two letters A and B, and then we put an arc above it. So you need to know the central angle. You need to know the length of the radius. And once you know those two, here's the equation that you're going to use. The measure of arc AB the first part of it is going to be a fraction. It's going to be the measure of the central angle divided by 360 degrees. This is going to give you a percentage of the circle the central angle takes up. So whatever the measure of this is, it's going to take up a certain amount. We want the percentage. So we're going to take the central angle divided by 360. And then we're going to multiply this by the circumference. We're going to multiply this by 2 pi r, which this part right here is your circumference. So if the circumference is, you start at point A and you go all the way around the circle, that's the length that we're talking about here. We need to know how much of that length we actually are using for our angle, or for our arc, so we need to know what that angle is. Take the angle, divide it by 360 degrees, and we're good to go. Now, I'm pretty sure I gave you a worksheet yesterday, and on that worksheet, sometimes the angles weren't in degrees. They were in what we call radians, with pi and all that. If it's in radians, what we're going to do is arc length is still going to be the same thing, but it's going to be whatever the angle is divided by 2 pi. So if you see degrees, we're going to use this one. If we see something with pi, we're going to use this guy right here. Now a sector, you could think of the sector as being the entire wedge right here. So the sector, that's kind of tiny, but that's going to be the area of the wedge. So the area of a sector now the area of the sector is going to be the central angle divided by 360, which is the percentage of the circle again, which is just like the arc length, but it's going to be times the area of the circle instead. So whatever this angle is here, if that takes up 30% of the circle, then this wedge is going to take up 30% of the area of the circle. And the arc is going to take up 30% of the circumference of the circle. So we have to know how much of the circle we have. And the only way to do that is to understand the amount of... We start with that angle. What's that angle? And then we kind of move from there. Now, I want to show some examples. I'm not going to draw really good circles this time, because they seem to all end up with a little bit of an issue there. Alright, so alright, here's the example. Find the area of the sector and length of the arc made by a central angle of, let's just say, 30 degrees of a circle with a radius equal to 4 centimeters. So I know that's a 4, that's a 4, that's 30 degrees. Now, if you want to, you can put A and B right here. It didn't really ask for that, but what we're trying to find now is we want to find the length of the arc, which is right there, and we want to find the area of the sector, which is going to be that wedge. Now let's do the arc length first. The measure of arc AB is going to be equal to, what's the measure of the central angle? 30. So it would be 30 degrees over 360 degrees. We're going to multiply this by the circumference of the whole circle, which is 2 times pi times the radius, r, which is 4. So, how much the zeros are going to divide out, but 3 divides into 36, how many times? 12 times. So that's 1 over 12 times 2 times pi times 4. Now, how many times does 4 go into 12? 3. So that 4 divides into 12 3 times. So this is going to be end up 2 pi over 3. And since everything is in centimeters, that's in centimeters, that's in centimeters, this is going to be in centimeters. So the length of this is going to be 2 pi over 3 centimeters long. So if we measured that, this is the exact value. If we used an estimate for pi, like 3.14 or something like that, 22 over 7, one of those, then we would have something that's not as accurate, but this is going to be 100% accurate. Now, the sector length, or the sector area rather, that's going to be equal to the same thing, 30 degrees over 360 degrees, because we still want to take that much of the circle times pi r squared, which in this case would be 30 degrees over 360 degrees times pi times 4 squared. Oh, I can't spell this morning. Now, from up here, we already did 30 over 360 is 1 over 12. So this is going to be 1 over 12. And I made this a little bit bigger because we could say that's going to be times pi times 4 times 4. Now, sometimes it's easier just to say, all right, well, do this. Now, does 4 divide into 12? How many times? 3. So I could divide out the 4 and the 12. I'll get a 1 there, and I'll get a 3 there. So this is going to be 1 times pi times 1 times 4. So it's going to be 4 pi over 3 centimeters squared. So when you have your circle, you need your central angle, you need your radii, and you're going to end up with these two different equations. Arc length is going to be the central angle divided by the 360 degrees times 2 pi r. The sector area, which is just basically like the pi piece, or the little wedge out of the circle, and that's going to be the same central angle divided by 360 times pi r squared. Now, I'll show you one that has radians in it and how you would deal with the radians. But first off, on this guy, any questions? Alright, now, that's absolutely terrible, but we'll go with it. Say this angle is pi over 6. And the radius is 5. So now, since the central angle's in what we call radians and not degrees, what we need to do is we need to use just a different form of the equation. So for arc length, we're going to go from A to B. If we want that length. So the measure of AB is going to be equal to whatever it is over 2 pi. Because 2 pi is equal to 360 degrees. So I can take this pi divided by 6 over 2 pi. Now don't freak out because there's a fraction over another fraction. We'll deal with that in a second. Now the length of the arc is going to be, we need 2 pi r. So we're going to use 2 pi r. So it'll be 2 times pi times, now what's the radius? 5. Now for this guy right here, we want to treat it like this. It's pi over 6 times 1 over 2 pi. When you have a fraction, it's like multiplying by a reciprocal. Now, what can we divide out? What's it? Is there something in the top and in the bottom that's the same that we can divide out? The pi's can go away. So I'll be left with 1 over 6 times 2. And that's the nice thing when you're dealing with radians. The pi's are going to divide out, and you're going to be left with numbers. This is really just 1 over 12. Now, I still have this guy I got to deal with. 2 times pi times 5. What's 2 times 5? That's 10 pi. So it'd be 10 pi over 12. Can I reduce that at all? Is there a number that can divide into 10 and 5? Okay. I could divide this by 2. If I divide 10 by 2, I get 5. If I divide 12 by 2, what do I get? 6. So this could be written as 5 pi over 6 as well. And it's just, I didn't specify anything, so it's 5 pi over 6 units. So it could be miles for all we know. Now the sector area is going to be the same thing. Pi over 6 divided by 2 pi times, now we have the area, pi times 5 squared, because now that's the area of the circle. Well, we already figured out what this guy was, wasn't it? Didn't we? That was 1 over 12. Because we did that already up here. We got 1 over 12. So I'll get 1 over 12. We can use that times, well, pi times 5 squared. Well, what's 5 times 5? Alright, 25. And that's 25 pi. So that's equal to 25 pi. Let me move that over just a little bit. Divided by 12. And that's units squared. So when you're working this type of a problem, what you need to realize is if you have your radians over 2 pi, it just ends up being a fraction times a fraction. And you can go from there. You're going to do that 100% of the time when you have radians here. And when you don't have degrees, this is what you want to do. If it's degrees, remember it's 306, or it's whatever the measure is divided by 360. 360. This one's divided by 2 pi. Now, if you really just hate using pi's and 2 pi's and all that stuff, then you can take that pi over 6 and say, I want to get rid of that. 2 pi is equal to 360. You can convert it if you wanted to and say, well, the pi's divide out. That's nice. 6 goes into this 6 times, so there's 60. And then that divides into that 30. So this is really equal to 30 degrees. So pi over 6 is equal to 30 degrees. And then you could say, all right, now I'm just going to do 30 degrees over 360 times 2 pi r. And then I'll use 30 degrees divided by 360 degrees times pi r squared. And that'll be your arc length. And there's your sector area. So if you want to convert it, that's how you convert it. Or even easier than that, pi over 6. 2 divides into 360 180 times. It's you do this. Pi over 180. The pi's divide out. 6 goes into 18 3 times. There's your 30 degrees. So you can convert like this. And then you'll just end up using these two equations. So if you don't want to use your pi's and your radians and have to multiply by don't want to multiply by reciprocals of fractions and all that kind of stuff, and you want to just avoid that, a simple conversion right off the bat, and you'll be all set. Like, for example, if your central angle is equal to pi over 4, you could just take pi over 4 and say, all right, well, the conversion factor is pi is equal to 180 degrees. Divide out your pi's, they go away, and then it's just 180 divided by 4, which is 45 degrees. So if you wanted to do that, you can. That's your option. Then you can use 45 divided by 360 if you wanted to do it that way. Doesn't matter to me. But I wanted to show you that you can convert and still use what you need to use.